to the channel. I hope you guys have been well. Today we will continue our video or our sessions on area and perimeter of 2D shapes, but today will be a revision exercise with regards to what we have already done in the first three parts of the series. This revision exercise will include the calculations of trapeziums, rhombuses, parallelograms, as well as kites. So please stay tuned to see how we actually calculate the areas and perimeters of these shapes as well. Okay. So heading into the first question, we will have a trapezium, as you can see at the bottom here. Then you'll also see that on the left side, the vertical line that runs from top to bottom is equal to 4 centimeters, and it also indicates that the horizontal line, which is at the top, is the same as that vertical line, which means that those two sides are the same length. So when we calculate the perimeter for that shape, for the trapezium, we will say P is equal to, and what you'll do is we'll start at the 4, we'll say 4 on the side there, 4 centimeters, plus 4 centimeters, plus when you carry on, you'll see that there's 5 centimeters, plus the bottom side, which is 7 centimeters. And if you add all of that together, you will find that the distance around the shape is 20 centimeters. Okay, so that's how you calculate the perimeter for that shape. Now moving on to the area for the shape. So to calculate the area of a trapezium works as follows. So you have area is equal to, now what they normally do is they divide the trapezium. So if it looks like this, they'll divide it into two sections with a diagonal line, which means that you'll have a triangle here and a triangle there. So basically, in general, in the long way, you are going to calculate the area of this triangle, the area of that triangle, and add it together. But there is a shorter way that we can do this. So let me show you. So you still start off with half, because the diagonal, like I've explained, divides the shape into two parts. Okay? What you do then is, after the half, you add the top measurement and the bottom measurement together. And what you then do is, at the end, you multiply this with the height of the trapezium. So if you can look at the trapezium on the bottom right here, you'll see that the top is 4 centimeters, the bottom of it, or the base, is 7 centimeters, and then the vertical line, which is the 4 centimeters, that is your height. So in order to calculate the area for the trapezium, you're going to say a half. What you do then is, we're going to add the top and the bottom together, and we're going to multiply that by the height, which is 4 centimeters. When you calculate all of this, the total area for that trapezium should then be 22 centimeters squared. And there you've calculated the trapezium. Is a kite. Remember, the first thing that you need to understand with a kite is that it has two diagonals. One that runs from top to bottom, and then the other one that runs from left to right. And another property with regards to the diagonals is that they bisect one another at a right angle, which is equal to 90 degrees. Okay. So first things first, as you can see at the bottom here, obviously I display all the questions on the bottom right, so that it is at your disposal while we are busy working, so that you can have a look at it. So you'll see that the one side is 50 millimeters. You'll also see that the other one is 0,095 meters. And they tell you that the total diagonal from left to right is 15 centimeters. And from top to bottom is 6 centimeters. Okay. Now, before you can even calculate the perimeter of the shape, you will have to go and convert the measurements to a measurement that is, how can I say, suitable to use. And in my opinion, because there is more than one measurement with the centimeter unit in it, I'm going to convert everything to centimeters, which makes it much easier to work with. So, to convert, you've got 50 millimeters as the one side, and to take millimeters to centimeters, you will then have to divide by 10. So we're going to divide by 10, and when you divide by 10, your conversion would then be 5 centimeters. Okay. Then the other measurement was 0,095, and that was meters. And if I have to calculate and convert meters to centimeters, I'll obviously have to multiply, and I need to multiply by 100. So it means that the comma will jump 2 spaces to the right, which will then give you 9,5 centimeters. So now everything is in centimeters. We are now able to go and calculate the perimeter of the shape. So from there on, you need to also understand another property of the kite is that it has 2 pairs of adjacent sides that are equal in length. So on the left side, those 2 sides would both be 5 centimeters, and on the right side, both of them will be 9,5 centimeters. So for the perimeter, that would be equal to 5 centimeters plus 5 centimeters plus 9,5 plus another 9,5 centimeters. And that will then give you a total of 29 centimeters, and that would be your final distance around that shape. Okay. Now we need to go and calculate the area of the kite. So what you need to understand is that the diagonal lines divide the kite into either 4 or 2 triangles. So either 4 right-angled triangles, or it divides it into 2 other triangles. So it could either be isosceles triangles if you divide it straight through the middle from left to right, or it could be obtuse angled triangles if you divide it from top to bottom. Okay. So in this case, to calculate the area of the kite, because you're also working with triangles, you will also start with a half, like you did with the trapezium. And what you'll then do is you just multiply the 2 diagonals with one another. So you multiply top to bottom diagonal with left to right diagonal. So you basically multiply the 2 diagonals together. That's the easiest way to do it. And then you multiply it by half. So the top to bottom diagonal in this case is 15 centimeters, okay? Because it's the longest diagonal of all of them. So 15 centimeters. And then the left to right diagonal is always the shortest one, so it would be 6 centimeters. When you go and multiply them with one another and multiply it with a half, you will get an answer of 45 centimeters squared for that area of the kite. Okay, and there you go, as easy as is. So multiply the two diagonals lengths with one another and multiply that answer by half and you get the area. Okay, moving on to the next question. Okay, our next question is a rhombus. So, the thing with the rhombus is, the properties that you should know is that it always has all sides equal to one another. A rhombus only consists out of lengths and not lengths and breadths. Okay. Then, to calculate the perimeter of the rhombus, in this question particularly, you'll see that you need to calculate the hypotenuse. So they gave you the height in the rhombus, which is 8 meters, and they gave you the base of the triangle, which is 6 meters. You need to go and calculate side AB to get every single side of that shape. Okay, so the first thing that we need to do is we want to calculate AB. So when we calculate AB, you know that when you calculate the hypotenuse, you need to add the base and the height together. Okay, so the base and the height, so it's going to be 6 squared plus 8 squared, and when we calculate everything, you'll see that 6 times 6 is 36, and 8 times 8 is 64. That will give you a total of 100. So AB squared is 100, but we're looking for AB, so we square root both sides. Therefore, AB is equal to 10 meters in this regard, because that is the unit of measurement that was utilized. So, because I've got the hypotenuse is 10, it means that all the sides of the rhombus is equal to 10. So when we do the perimeter of the rhombus, it's going to be 10 meters plus 10 meters plus another 10 meters plus 10 meters, or you could simply say perimeter is equal to 4 times 10 meters. And the only reason why you can do that is because all the sides are equal. It's the same as working out the perimeter of a square. Multiply it by 4 and you'll get your answer. So therefore, at the end of the day, you'll have a perimeter of 40 meters in this regard. Okay, so that is the perimeter sorted. Now, to calculate the area of a rhombus, the way that you do that is that you work with the you work with the height as well as the base of the shape. So the two lines that are perpendicular to one another, the height and the base, those are the two measurements that you work with. So to calculate the area of the rhombus, you're going to say base multiplied by height. So in this case, the base is 10 meters and the height is, in this case, 8 meters. So if you multiply it together, you'll get that your total area of that shape is 80 meters squared. So there you go. Calculated, done and dusted. Okay. Another thing to keep in mind, I'm going to do another question now where we work on a parallelogram, but the formula for the area for a rhombus as well as for the parallelogram, exactly the same. No catches onto it or anything like that, it's exactly the same. So let's quickly do the parallelogram and then we will take it from there. So with the parallelogram, as you can see at the bottom here, it's got a height of 12 centimeters, and then at the bottom it's split up the side AB into 5 centimeters as well as into 6 centimeters in this regard. So what we are sitting with now is we're sitting with a height. The height is obviously the hypotenuse of the right angle triangle. Then they gave us the 5 centimeters, but we need to go and calculate side AD. Now, to do that, exactly like the previous question, Pythagoras is needed in order to complete this question. So first things first, we need to calculate side AD. So to calculate side AD, you need to now keep in mind that AD is the hypotenuse of this question. So we need to add 12 and 5 together in order to give us the hypotenuse. So we've got 12. Let me just see the unit of measurement, centimeters squared, plus we've got the 5 centimeters squared in this case. So when you calculate it, you'll get 144 if you multiply 12 by itself, and 25, which will give you an answer of 169. So AD squared is equal to 169. If we square root it, which is what we have to do, therefore AD would then be equal to 13 centimeters. Okay, so from there onwards, now I can go and calculate the perimeter as well as the area. What you also need to keep in mind now is that side AD and side BC are equal to one another in length, due to the fact that a parallelogram has 2 pairs of opposite sides that are equal in length. So AD and BC are equal, and then AB and CD are also equal in this regard. So the way that you can calculate the perimeter of the parallelogram is as follows. You can use the long method, where you then say 11 centimeters plus 13 centimeters plus 11 centimeters plus 13 again. That's a very long method, the way that you would also be taught in primary school to calculate a right angle, or rather a rectangle perimeter. Or you can use the other method that I like to use, and I use it with the rectangles as well. Perimeter is equal to 2 times the length plus 2 times the breadth in this case. So you can say 2 times 13 plus 2 times 11, and if you add it all together, it will give you a total perimeter of 48 centimeters in this case for this shape. Okay, 48 centimeters for that shape. If we move on to the area of the shape, it is exactly the same as what you would have done with the rhombus. You're going to multiply the base and the height with one another. Now remember, the learners always ask me, how do you know which one's the base and the height? The height is obviously the straight line that is drawn inside the shape, and the base is the line that it is perpendicular to. So where the two meet, it creates a 90-degree angle. So the base and the height meet perpendicularly, and that would then be the two sides that you use. So in this case, we've got then 11 multiplied by 12. Remember, base, height. And if you multiply those two together, you'll get a total area of 132 centimeters squared in this regard. Okay, that's it for that question. We're going to move on to a question that's a bit more, if I can put it this way, a bit more difficult. We're going to start working now with shapes that are combined, so irregular shapes. Okay, so let me just clear the board here. Let me quickly jump into that. So you'll see with regards to this shape, it has a triangle as well as a rectangle included in it. So the first thing that you need to understand is that you need to go and check which sides are equal to one another, which sides can I get measurements for, or where must I do calculations, etc., etc. So you will obviously pick up that GA, side GA in this question is 4 centimeters, okay, because of the indications that were given to you with regards to that shape, okay. So how you can take it is, because it's divided into grids, you can say that GA is 4 centimeters, and the reason for that is because the opposite sides of a rectangle are obviously equal in length, okay. So because GA is 4 centimeters, you would then know that you've got a right angled triangle, and you need to go and calculate the hypotenuse of that right angled triangle. So the triangle that I'm going to use is, and the side that I'm going to calculate is going to be side AB. Side AB. Okay. So first things first that you need to pick up is that GA is equal to 4 centimeters. And the reason for that is because it's opposite sides of a rectangle. Okay, opposite sides of a rectangle. Then I need to go and calculate side AB. So I'm calculating side AB due to the fact that I know that what do you call it? AB is the triangle that I need, and because it's divided up like that, AB and AF should then be equal, but I first need to find the hypotenuse AB. Okay. Then with that, I'm going to use the following measurements to calculate for the hypotenuse, which is AB. So the first one is, I'm going to use 5 centimeters because that is the height of the triangle, and where I find that is represented there by GB. Okay, so 5 centimeters, and I'm going to add that to the 4 centimeters that I find where they told me that GA is 4 centimeters. And remember, this all has to be squared. Okay. Now, this is 25, this is 16, okay. When I add them together, I'll get 41. So I'll have AB squared here. We're going to square root them, and because 41 is not a perfect square, you leave it as answer square root of 41. Work with it that way because it's very accurate when you have to go and round off at the end of your question. So the reason and what the method that you followed here was obviously Pythagoras. Okay? And what we need to do now is we need to go and calculate the perimeter of that shape. So to calculate the perimeter, you're going to have more than 4 sides that you're going to add together. Okay? So, with that said, I'm going to start right at the top where BC is. I'm going to move clockwise all the way back to AB. Okay, so the perimeter of this shape. So, if I start at BC, it's 4 centimeters. Plus, if I move on, I will get 6 centimeters. If I carry on, I'll get another 4 by FE. When I move on, I will obviously get the square root of 41 because the 2 sides of the triangle is equal. So the square root of 41 plus another square root of 41, which is the one that I calculated for AB. Okay. When I add this together and round it off to 2 decimal places, I'll get 26,81 centimeters for the perimeter of the shape. Okay, now the area of the shape you need to be very careful with, because obviously you have 2 shapes that you're working with. Number 1, triangle. Number 2, rectangle. So you know, do 2 areas and add them together. So the area is going to be as follows. So A equals, obviously the triangle is half base times height, plus the area of the rectangle will be length times breadth. Okay, so half the base of the triangle in this case is 6 centimeters. The height was given to you, it is 5 centimeters. Then the length of the rectangle is 6, and the height or the breadth or the width of this rectangle is 4. So 6 times 4. Obviously you guys will slot all of this into your calculator, and you will then get a total area for this irregular shape of 39 centimeters squared. And there you go. You've calculated the perimeter as well as the area of the shape. Okay, cool. Let's move on to the next question. Our next question on display over here will be as follows. Let me just see. Okay, so if you look at the shape on the bottom right here, you'll see that it has two triangles, a rectangle, as well as a semicircle. So you're going to do quite a bit of calculations over here. Okay, so we are going to start off as follows. We're going to do Pythagoras, because obviously you want the height of the right angle triangles, because the height will assist you to calculate the area of the rectangle. Okay, then after that we will calculate the perimeter of the shape. Okay, and I'll show you exactly how to do that, because you now need to combine three different shapes basically. Then after that we're going to calculate the area, and we will work through that as well to ensure that you understand what is expected of you. Okay, so first of all, let's start off with Pythagoras. So I'm going to work with triangle ABE, which is on the left here, as you can see, because they gave me the hypotenuse as well as they gave me the base of the triangle. Now to calculate the height, we always subtract the base from the hypotenuse. So the height is named AE, and we take the hypotenuse, which is 5, and we subtract the base from the hypotenuse, which is 3 centimeters. That will be 25 minus 9, and that should give you 16. But remember, you don't want 16, so you need to square root. So therefore AE is equal to 4 centimeters in this regard. So the height is 4 centimeters. Okay. Now to calculate the perimeter of this shape. Remember, you've got the circumference of the circle that you need to calculate, and then you need to add all the other sides together. So what you also need to pick up is that AB and DC are equal in length. Okay, so they're both 5. And then BE and FC is also equal to 5. And then what you need to also understand is that side EF is exactly the same length as side AD, which is 10 centimeters. So in order to calculate the perimeter for the shape, you need to do the following. So we need to calculate the circumference. So we say half of that circle, 2 pi, and then the radius of that circle would obviously be 5 and not 10. The diameter is 10. So how I got that was, if you look here quickly, to calculate the radius, you say equal to diameter divided by 2. So therefore you say R is equal to 10 divided by 2. Then we know that R is equal to 5 centimeters in this case. Okay. Please do not use the diameter. So the diameter is different from the radius in the way that the diameter stretches from the circumference through the center to the other side of the circumference, where your radius stretches from the center of the circle to the circumference, and the radius is always the one that you need to use. So we use the radius over here. So there we go, that's the formula as well as all the substitution for the circumference of the circle. Then we add the following together. So we then add the side of the triangle, which is 5. So side that I'm talking about is side DC. Another thing that you need to keep in mind is that even though EF is 10 centimeters at the bottom, you need to include side BE and side FC. You need to add those two 3's together and add it to the 10. So it would be 3 plus 10 plus 3 gives me 16 for the total of the base. And then I add the other side of the triangle, which is side AB, which is also 5 centimeters. Okay, so when we go and calculate this, you should get a total perimeter rounded off to 2 decimal places of 41,71 centimeters. Okay, that's the perimeter sorted. So with that, let's calculate the area quickly. So the area of this, you'll have to do the area calculation for the semicircle and also the area calculations for this. Okay, but if you look at the bottom, A, B, C, D, that is a trapezium. And remember, in one of the previous questions I said to calculate the trapezium, all you do is you add the top and the base together and multiply it by the height and divide it by 2. Okay, so to calculate the area of the semicircle, we're going to say 1/2 pi times the radius, which is 5 squared, plus the area of the trapezium. So the area of the trapezium is 1/2. Open it up, then we say the top of the trapezium, which is 10, added to the base of the trapezium, which is not 15, sorry, it's 16, multiplied by the height. And you've calculated the height. The height is 4 centimeters. You've calculated the height here, just to explain it to you again. So, area of the circle, area of a trapezium, top, bottom added together, multiplied by 4, divided by 2. That will give you a total area of 91,27 centimeters squared. And that is the area of that shape. Okay, we are done with that now. Let's quickly move on to one final question, and once that question is completed, then we are done for the session. So this would include your revision and everything else that you would need to know with regards to calculating other irregular shapes. Okay, so our last question as displayed is a regular pentagon. Okay, as you can see on that shape, that a regular pentagon is made up of 5 congruent isosceles triangles. Okay, 5 congruent isosceles triangles, keep that in mind. So in this shape, they give you the height and they give you the hypotenuse of the one triangle. Okay, so you need to go and calculate the base of the triangle, and we are working with the triangle at the bottom. You will see that the height is 16, hypotenuse is 20. We need to calculate for CD. So when you calculate for CD, you're going to get the base for FD, and obviously the base for FD is going to be the same for CF, which means it makes the one side equal to 24. So, starting off with Pythagoras. So we're going to calculate for side FD, that's what I'm going to calculate for. So FD squared, we're calculating for the base, so we subtract the height from the hypotenuse. Okay, so the hypotenuse is 20. The height of that triangle is 16. When we calculate everything, you should get that FD squared is equal to 144. When you square root that, FD would therefore be equal to 12 units. Okay, so if FD is 12 units, therefore CD, which is the total base of that pentagon, CD would then be equal to 24 units. Okay, now we need to go and calculate the perimeter of the pentagon. So the pentagon has 5 sides that you need to work with, which means we take CD and we multiply it by 5. So for the perimeter of the shape, we're going to say 5 multiplied by 24, and you will then get a total perimeter of 120 units. So the distance around the pentagon is 120 units. Then on the area for this shape, you would know that there are 5 isosceles or congruent isosceles triangles in it, and you need to know the area formula of a triangle. So there are 5 of those triangles, okay? And the formula for the triangles is half base times height, as you should have learned by now. So we're going to say 5 half. The base of the triangle is 24. The height of the triangles will be 16. If I calculate this and I multiply the area for all 5 of the triangles, I would get a total area of 960 units squared. And there you go. There you've calculated the total perimeter as well as the total area for that shape. Well guys, that is it for this session. I hope that you have learned something with regards to calculating area and perimeters of other polygons, and not just the normal squares and triangles that you work with daily. Remember that this can help you because the teachers do sometimes throw in something that is different, if I can put it that way, and hopefully you will then be able to calculate everything accordingly. Please get other guys to join our channel, to grow it, to ensure that we reach as many people as possible, to assist them, as well as to expand their knowledge on the subject. Thanks once again for joining in. I hope you have a good day. Bye-bye.